Hey guys, I know that some of you are having troubles with question 5 on the Binomial Theorem 2 worksheet, so I'm just going to kind of post some solutions to that here and walk you through the process of solving them. So question 5a asks you to find the coefficient of x to the power 5 in the expansion of x plus 2 times x squared plus 1 to the 8. Now this is a little bit different than the ones we've been looking at in the past, in that previously we would kind of not have this. We would just have one big expansion. So now we have one big expansion, and then we're multiplying it further by x plus 2. And obviously, when the x multiplies all of those terms, it's going to change the exponent on each x in your expansion. So first I would say let's look at the expansion of x squared plus 1 to the 8. And we'll do that using the binomial theorem. The general term in this expansion looks like 8 choose k times x squared to the 8 minus k times 1 to the k. And note that 1 to the k doesn't really do anything, because 1 to any power is 1. So it's really x to the 16 minus 2. Now, because of that x plus 2, we are taking all of these terms and we're multiplying them all by x plus 2. So that's what our expansion is going to look like. We're taking x plus 2, we're multiplying all kinds of terms of the form a choose k times x to the 16 minus 2k. So really we're distributing. We're taking x and we're multiplying it by these terms, and we're adding them to 2 times all of these terms. So we get x times a choose k times x to the 16 minus 2k. Some terms will look like this, and other terms will look like this. And we can simplify this a little bit further, because the left term is x to the power 1. So if we combine it with the x term, or x factor that's already there, we get a choose k times x to the 17 minus 2k. And our other term will leave in that form. Now we want to find x to the power 5. So potentially an x to the power 5 term could come from these left terms, or it could come from these right terms. So we have to look at each of those separately. Now let's look at the left. So to get x to the power 5, what we would need k to be 6. Because if k is 6, we have x to the power of 17 minus 12, which is 5. Great. Now let's look at the right. Is 16 minus 2k ever 5 for any integer value of k? No. 16 minus 2k, if we set that equal to 5, that's like saying 2k is 11, or k is 5.5, which we don't accept, because these k's represent term numbers, which need to be positive integers. Okay, so any x to the 5 term comes from a choose k x to the 17 minus 2k when k is equal to 6. So now we plug that in. We get 8 choose 6, and that's it. That will be our x to the 5 coefficient, which is equal to, let's use our formula, 8 factorial over 6 factorial times 2 factorial. And we remember our little manipulations of these factorials we can do. 2 factorial is just 2. These 6 factorials cancel, so we get 56 divided by 2, which is 28. So therefore, the coefficient of the x to the, this is 6 or 5, sorry, I keep forgetting. This is x to the 5 is 28. So to recap what we've done here, we've used the binomial theorem to expand the x squared plus 1 to the 8 term, a big expansion. We figured out that all of the terms have this form. And then we're saying, okay, really what we're doing is we're taking all the terms of that form and we're multiplying that by x plus 2. So we go here, we distribute that x plus 2, and we come up with two different types of terms in our expansion. This one and this one. The leftmost changes the power on x, so we have to consider both types of terms separately. And in fact, in this particular case, only the left terms could really contribute to an x to the power 5 term. We figured out we needed k to be 6, and we substituted it into the general form for those terms and got 28. Now, question 5b is a similar but slightly more tricky example. So we're doing kind of the same thing where we have some big 3x plus 1 to the power 9 expansion. And then we're multiplying by 2 minus x. And we'll see how this one is a little bit different than the previous example as we go. So first, let's look at just the expansion 3x plus 1 to the power 9. That has general terms. So the general term for the expansion of that is 9 choose k, 3x to the 9 minus k times 1 to the 9. And we're lucky again in that 1 to the 9 doesn't contribute anything. So then we get 3 to the 9 minus k times x to the 9 minus k. Okay, not bad. So now we need to distribute. So what we're doing is we're taking 2 minus x and we're multiplying it by these terms of the form 9 choose k, 3 to the 9 minus k, x to the 9 minus k. And okay, once again, what we're doing here is we're distributing. We're multiplying the 2 and the negative x by those. So we end up having terms that can look like 2 choose 9 minus k, 3 to the 9 minus k, x to the 9 minus k, or negative x times 9 choose k, 3 to the 9 minus k, x to the 9 minus k. And we can't really simplify the left terms, so I'll recopy those. But we can combine the x's here. So we get x to the 10 minus k. Great, so once again now, we need to look at how we can get an x to the power 6 from each term separately. So the left family of terms, well, if k equals 3, you will get x to the 6 terms, okay? And on the right rather, if k equals 4, you will get x to the 6 terms. So we need to calculate what happens when you plug in k equals 3 to the left type of terms, what happens to k equals 4 to the right terms, and then we need to add those together. So then we'll have two terms with x to the power 4. If those are like terms, we can combine them by adding their coefficients. Sorry, x to the power 6, we can combine those by adding their coefficients. So let's look in the case of the left term with k equals 3. We get 2 times 9 choose 3, 3 to the power of 6, x to the 6. Okay, and that is 2 times, okay, let's do 9 choose 3. 9 factorial over 6 factorial times, I'm going to call 3 factorial, 3 times 2. Which is 9 times 8 times 7 times 6 factorial. do some canceling. 6 is gone. 3 goes into 9 3 times. 2 goes into 8 4 times. So we have 4 times 3 is 12, and 12 times 7, 84. So this is 2 times 84 times 3 to the 6. I'm going to, I would not expect you to do that on paper 1. So I will tell you what, I'll use my calculator here and calculate that. 3 to the power 6, 729. Times 729. And let's do this on my calculator, times 2 times. So we get 100. The sum of the x to the 1x to the power 6 term we get in the expansion is 122,472. Great. So now we need to look at the right terms when k is equal to 4. So when k is equal to 4, we get negative 9, choose 4, 3 to the 5, and then x to the 6, of course. Okay, let's do 9, choose 4 over here. 9, choose 4. You could just do this on your calculator because it's a paper 2 question. 4 factorial, 5 factorial. Now 9 is 9 times 6 times 7 times 8. Mess that up. 9 times 8 times 7 times 6 times 5 factorial over 5 factorial times 4 times 3 times 2. Let's cancel out the 5 factorials. 3 times 2 is 6, and 4 goes into 8 twice. So this is 9 times 14 here, which is 126. So this equals 126. This is negative 126. Let's see, what is 3 to the power 5? That would be 243. 243 x to the 6. So these x to the 6 terms have the form negative 30,618 x to the 6. And let's not forget what we're doing. We're adding all the terms like this to all the terms like this. So the x to the 6 terms need to get added together to get the overall coefficient for x to the 6. Okay, so let's see what we get. We get the one on the right. And the one on the left is 122,472. We're going to have terms that look like a term that looks like this, a term that looks like this in our expansion. So we can add those together to get, do this on my calculator so I don't make a mistake. Plus 122,472. It's 91,854 x to the 6. So as you expand this, you will, and if you do full simplifications, you expanded this whole thing we started with, you would end up with an x to the 6 term with a coefficient of 91,854. So I hope this clarified a little bit. These are pretty much as tricky as they get in terms of binomial theorem questions. So if you can really answer questions like this, you will be in very good shape for the test and exam.